Okay, hey guys, so I've not released one of these tutorial videos for a while. Just had a lot of remodelling being done on the house at the moment, so just trying to sort it all out. But we're back. This code may be slightly different because I cocked up quite majorly and somehow managed to delete every comma, and it just ruined it completely. And with this project, I've got, I think, almost 100 classes, and it is taking an age to replace them all. So instead of replacing them all in this, I just completely rewrote it to see what would happen. So yeah, but for this tutorial, what I'm thinking of doing is, what am I doing? I'm going to be doing Spritesheets. Let's kill that. This is going to be, yeah, indeed, dimension games on with times scale. Oh, I should have fixed it. Yeah, there we go. Huh, okay. Yeah, okay, ignoring that. Let's just get rid of that. But, how did I do that? Let me just grab it from here. With scale, with height. With pixels, yeah. Okay, stuff up. Okay, right. So in order to do this, we're going to need to make a few new classes. So in tutorial, I'm going to create a new folder. I'm going to call it Sprites, and I'm first going to create a new class in the main tutorial and call that Screen. Okay. So we're going to have a public void render. What we're going to have next? We're going to have. It's going to take a few parameters. Int tile, int x pos, int y pos. Cancel that. What do I need? 2 minutes. Let me just pause this. Okie dokie. Sorry about that, I just need to go and sort some stuff out outside. So we'll just replace that. So it'll be x pos y pos tile, int width, int height. Just sort that. Okay, and then we're going to say loader dot grab tile, tile width height. Now loader, we're just going to create it before it actually exists at the moment. So Spritesheet loader equals new Spritesheet loader. Okay, and now in Sprite, it's going to create a new class called Spritesheet loader. And we're going to have a few things in here. So public int sheet pixels, public sprite sheet loader, okay, that'll be it, and public void, what was I called it? Grab tile? Yeah, grab tile. Grab tile. Int tile. Int width. Int height. And then we're going to say sheet pixels equals new int width times height. Pretty simple to start with. Okay, now we're going to. Right, yes, there we go. That's fine to do. Buffered image. If I know, we'll call this sheet. and now we're going to make our sprite sheet loader take a buffered image parameter. This dot sheet equals sheet, and we'll call this sheet. And this will this may look a bit weird, but it's essentially saying that the class is sheet variable, so that is equal to this is sheet variable that. So let's just grab them, import the buffered image, and go back to game. Now we're going to use the init class. So in the initialize class, we're going to say private sprite. I don't know, we'll go public. Public sprite sheet loader. Loader equals new sprite sheet. But no, just call it loader. And then down here we say loader equals new sprite sheet loader, and we'll say what's this, game dot class dot get resource as stream tiles dot png. Okay, now just have to import sprite sheet loader. And why is that going to throw an error? Okay, dot get image. Why is that not working? No, we just figure this out for a sec. Okay, need to get rid of dot get image. Image IO dot read, and that should work. Just import image IO, and surround with a try catch. So actually we'll just clean this code up a bit. Sheet buffered image sheet equals sheet. Okay, and then we'll just say sheet equals new sprite sheet equals image IO, so read, and then we'll just say loader equals new, and then just give it the parameter of sheet. Just initialize it to null. Okie dokie. Now what? Okay, yes. We'll just create the sprite sheet. Now this is going to be quite a long tutorial because this isn't the simplest of things, but it's not good to just start and then stop because it'll just go horribly wrong. So paint.net, I use this personally, but it's up to personal preference. So width is going to be 256 and we'll just say 512. Don't maintain aspect ratio, 256. Okay. It's going to give us quite a nice big thing. Now this is quite important. Just pick any colour as your right click, so your secondary colour, and then for your primary colour you want true pink, FFOOFF. That's because we'll be using that to imitate transparency. And then I've got a fantastic little plug-in here called Grid Maker, and I just need to swap those over. So checkerboard marker, and then just set this to 16 pixel tiles. So 60 pixel tiles, and brush width 1. That's just going to give us a massive grid. In fact, make this colour black. Oh no, that'll be alright. And I'll just fill it all with black. So that should do. No, that failed miserably. There we go. So that's our sprite sheet. I'll provide a link to this in the description if you don't want to make it. Then just creating new layers is helpful. It just allows you to organise everything a lot more. So just zoom in a bit, and we'll grab the first tile, which goes up to those boundaries there. So that's a 16 by 16 tile, and we'll just pick a nice greeny colour, that colour. Hit backspace to fill it, and then we'll just hit store. No, where is it? Noise. Add noise, and then just drop the intensity down, drop the colour saturation a bit, and that gives quite a nice tile. And now these tiles can literally repeat infinitely, and you just don't notice it. And you'll be able to see that in a minute. Just quickly before we do that, in here you're going to need to create a new class called res for resources, and then right click tutorial, or whatever your project's called. Go to properties, and then Java build path, and then you're going to want to add a library, I believe, yes, a library, and then add a class folder. Get rid of all these because these are irrelevant. Go to the one that you're working on, so tutorial, and click res. Okay, that should load it, and then that, if you refresh this, it should come up with a little symbol there, and that's now loading. I just noticed a little error here. That's meant to have a back forward slash in front of it, so it should be /tiles.png. Okie dokie. So now in paint.net again, we're going to save this as a paint.net file. So just navigate to your workspace. If you go to desktop, computer, if I know, just go to your desktop, you should have a folder called your name, so mine's Matthew. Go down to workspace. That was my old workspace, I remade it here, so workspace game, tutorial, res, tiles.paint.net, and I'll save it again, but as a PNG file. Now I want auto detect on there, and save it, and it's going to flatten it, so then just go into history here, and then click deselect, so you go above the flatten, so now you have your layers back, and just create something, and it'll get rid of the flatten, so you can continue working on it without a flattened image. So now minimize that. If we refresh res, we'll now have two files there, paint.net and PNG. Okay, so now sprite sheet loader. Okay, yeah, we can get rid of that, and then we need to create a constructor for screen. So public screen, and we're going to create a private sprite sheets loader. Loader equals null. I don't need to initialize it yet, so I'll just copy that, organize that, so grab the input, screen, loader, this dot loader equals loader. If you want, you can just rename this to new loader, and then this to new loader as well, and it'll still do exactly the same thing. Why? What haven't I got here? How's that giving me an error? Let's just save it, see if it gets rid of it. Yeah, there we go. Eclipse does that a lot, it's quite annoying. But, c'est la vie. Okay, so we've got grab tile. So, in Sprite Sheet Loader, we should have a sheet. Okay, so now is where the complicated maths comes in, and I'm not going to do this off the top of my head because I'll probably guess it wrong. So in this paint.net, this notepad document even, I've got the classes that I'm recreating here, so Spritesheet loader, and I'm going to just demonstrate what it's actually going to be doing. So this is the maths that we're actually going to need, and it's quite important. If this goes wrong, everything goes wrong, and you just can't load any pixels. So we've got your width and your height, offset and tile. I forgot about the offset, but you don't really need offset, but we'll add it. In fact, no, because you never use offset. Okay, so int x tile equals tile mod 16. So yes, modulus 16. That's essentially giving you the remainder. So if it's 17, it'll give you 1. If it's 18, it'll give you 2. Basically that. And then int y tile equals tile divided by 16. And this is an integer divide. So if it's 21 divided by 16, it'll give you 1. Okay, so now we're going to have some loops for int y equals 0. Y is less than height y plus plus for int x equals 0. X is less than width x plus plus. Okay. Sheet pixels, I think, yeah. Okay, ignoring that. I'm going to need to create a few new variables, so blick int pixels. Is that pretty much it? Nah, sheet width. Sheet width is irrelevant, really. No, it isn't. I do need sheet width. Okay, so int x, y, sheet width. Okay, so buffered image sheet. We'll get rid of that. I don't believe. Sorry to keep checking back on this, but I really don't want to get this wrong, because this is going to be the backbone to the whole engine. Okay. Buffered image equals new buffered image sheet dot get width sheet dot get height buffered image dot type, and you're going to want to get int argb. Okay. Now, okay, sheet pixels equals image dot get data. It's going to be okay. No, never mind. Okay, image dot get it's draw, I believe. It's image dot get graphics dot draw image sheet 0,0, null, and we can just get rid of all of this. Okay, this is basically to convert from a RGB type buffered image, which we're being passed in here, which we can't change thanks to paint.net. I'm just creating it to give it an alpha value. Okay, so now we're just going to say sheet pixels equals data buffer int image dot get data dot get raster dot get data buffer, or is it dot which one? Yeah, dot get data. Okay, this is gonna take, yeah, there we go. That's just that imported, and I believe, yeah, that's it. Except I just want to say sheet width equals sheet dot get width. Okie dokie. Now we'll just continue with this GrabTile method. Okay. Okay, just pixels x plus y times width equal, that should be right. No, just a placeholder. Just keep that 0. Boy, they how long are we on? 21 minutes. Okay, so it's a fairly long tutorial, but it is worth it. So sheet pixels x plus x tile times width. Yeah, this is right, I believe. Plus y plus y tile times height times sheet width. Okay. I believe that's right, is it? Yeah. Okay. Okay. Now we're just going to go into the screen and actually formulate our render method. Actually, we're going to need to give these some new parameters. So int width, int height, private int width, height. Yes, I know they're unused. This dot width equals width. This dot height equals height. Okay. What are you gonna say now? No, I don't care. Okay, go away. They're not unused. Okay. Okay, we're gonna create two ints here, x offset and y offset. But we'll just set these to 0 for now. We're not actually going to use them right at this second. That'll be coming in a few tutorials time, but that's basically how we're going to make our movement. Okay, so for int y equals, try to spell, y equals 0, y is less than height, y plus plus, for int x equals 0, x is less than width, x plus plus. Okay, now this is where the fun begins. Okay, x pos minus equal x offset, y pos minus equals y offset. They're just some placeholders, we're not actually going to use them just yet. And I was going to do a little bit of validation. Okay, we're basically going to want to say if our y position plus the y offset basically exceeds the boundary, so if it's less than 0 or greater than our height, just skip the rendering, just don't even bother. So if y pos plus y offset no, sorry, ypos plus y is greater than 0, or ypos plus y is greater than equal, sorry, less than 0 and greater than or equal to, less than 0, greater than equal to height, continue. And we're going to say the same here. So if xpos plus x is less than 0, or xpos plus x greater than equal to width, continue. Okay, and now this is where we're actually going to make use of the render method here. Okay, we're going to create an integer to get the colour value of the pixels in the sprite sheet. So int col equals loader.pixels. Jeez, can't type today. Pixels. Now what is it going to be? It's going to be x plus y times height. Let's get the pixels. Just realised this. We're going to need a pixels array. God, this is a terrible tutorial. Width times height. Public int pixels. Okay. Now, if col doesn't equal, now I'm going to quickly grab this using this brilliant little program that I wrote earlier. It's basically just a bit shifter. 25 255 0 255. So minus 65281. 65281. Minus 65281. If it doesn't equal that, pixels x plus xp. Well, xpos plus y plus y pos times width. I need to spell pixels right. Pixels. Save that. Oh, why? Ah, it was a new int. Well, that's my fail there. Stop typing that. Equals col. Okie dokie. Okie dokie. Time to test this. Now this should work. If not, I'll pause the recording and do some quick learning. Okay, so I need to correct screen class. So what's not class? Sorry. Yeah. So okay. So it's initiate. Okay. Screen equals new screen width height coda. Private screen. You will be using a second. Okay, so take screen.render 0 0 tile 0 width 16, height 16. Okay, moment of truth. Okay, it's a little too big. So what's that? It's going to be 360, 240. Okay, so that's not working. Let me just do some quick browsing to find out what's gone. Okay, guys. Is that resumed? Yeah, there we go. Half an hour, Jesus. Okay. I found a cocker. I just added this, just a quick sleep thing, so it gives our program a little bit more memory to run everything else. But I just realised, we've got a great little array of pixels there. That is completely full, but we never set it to anything. So for int I equals 0, I is less than screen dot pixels I plus plus screen dot pixels dot length find dot length pixels I equals screen dot pixels I. Okay, that should work. Yeah, there we go. There's our tiny little 16 pixel thing. So if we just shift that over by, say, 10, draw it at 10, 10, run that, and there we go. Tiny little thing. Okay, I'm just trying to quickly try to figure out a little bug, but I think I've got it. We're just gonna rename this. So for int y equals 0, y is less than screen dot screen dot width y plus plus. Okay. Just go into our screen thing. Just change this from private to public. Public int. Yeah. So height for int x equals 0. X is less than screen dot width x plus plus. Right, and now what else we can have? Pixels x plus y times width equals. Oh, why are you dying with that? Name that. That's not called width. That's width equals screen dot pixels x plus y times screen dot width. Now is that going to work with the scaling? Hopefully. No. What's gone wrong there? Just a second, guys. Okay, guys. Because I lost the previous one of these and I had to quickly rewrite this code, I missed out quite a major bit here. Get width, get height, which you guys should have, which is why you wouldn't have been seeing the same error as I did. So now that should work, and if we run it, we have that appear. So now if I just go up here into tick, if I just cut that, and I'll go down to the up to the init class, and then just go for int I equals 0. I is less than, and let's say, y equals 0, y is less than 16, y plus plus. For int x equals 0, x is less than 16, x plus plus. screen.render x times 16, because it's 16 pixel tile. X times 16, y times 16, 0, 16,16. So organize that. That should just build us a nice square. So now you can see that's the basis of our engine built. And you can see there's some evidence of tiling. You can see the repeating bit there. So basically all you have to do is get rid of that, zoom into this, select it, and I'll just demonstrate how simple it is to create a new tile. So if I copy and paste that, why is it? There we go. If I just I had the wrong one open, copy and paste this, that'll just give me a second grass tile. If I then just draw a simple rock, just fill it in, maybe give it a little bit of shading, just go a bit darker, put it down here, and a bit lighter up here, even lighter. And just it's a really bad rock, but it's just a simple demonstration of how simple it is. And then 200% is the size that you'll see them on screen. So if I now save that, save as PNG straight off, yes, close it, auto detect, yes, flatten, let's get rid of flatten, close that. And now if I just run this again, I've got that. So where's it? Okay, so random equals new random. Oh, just import random. Okay. Screen.render random dot next int 16 times 16. So if I just paste that again, oh crap. So then 1 this time because it's our first tile, and if I save that, that should give us, hey, one randomly placed tile, and that's how simple it is to add new tiles. So hopefully this is going to give you a lot more freedom whilst I sort out the next tutorial, which should be movement. Won't be a player yet, but we'll have movement in, add some movement in, and then we'll look at getting a player made. So thanks for watching, guys, hope you enjoy, and sorry for it being such a jumping tutorial, just jumping around getting some of the code wrong, but as I said, I just did not want to get any of the maths wrong, because if the maths goes wrong it just completely ruins the program for you. So hope you enjoy, and I should hopefully be recording another tutorial soon. So thanks, bye.